All right, let's do this. Unit 8, right triangle trigonometry. Hey, just 2 sections, so you're welcome. Let's get started. We'll just do some notes here. You can follow along, fill it in, whatever you need. So just as a reminder, I'm sure you've seen this somewhere before, but the Pythagorean theorem means we're dealing with right triangles, okay? And we're talking about the sides of the right triangle. So the side opposite the 90-degree angle is always the hypotenuse. The other 2 sides are called legs, and we give them letters. So like over here, you say, okay, this is a leg, and C is the hypotenuse. So over here, I would say, okay, A and B and C. So your formula is if you square the length of this side and you square the length of the other leg and add those together, that's going to equal the hypotenuse squared. So that's where we get the formula of A squared plus B squared equals C squared. So we can use that to find A or B or C, given that you know 2 out of the 3. So if we go to this example right here, this is a leg, this is a leg, that's the hypotenuse. So we would say 4 squared plus 8 squared equals x squared. That's how we would solve. Then we just plug it in. So 4 squared is 16, and 8 squared is 64. 64 plus 16, that would be 80. So we have 80 equals x squared. Or you could write it as x squared equals 80. It's the same thing. Now, once you get to this point, we have to square root both sides. So if I square root both sides, I get x equals, now it's going to be the positive value, so we're not going to have a negative length, so we'll say the square root of 80. Then we simplify the square root of 80. We always simplify. The largest square number that divides into 80 would be 16. So it would be 16 times 5. So square root of 16 is 4. So 4 square root 5 would be the length of that side. Okay? What about this one? Well, this one, we have a side squared plus the other side squared. When I say side, I mean the legs. Okay, so one leg squared plus the other leg squared equals the hypotenuse squared. So this one now we're going to solve for one of the legs, not the hypotenuse. So, but we do the same thing. So this is x squared, 22 squared. Let's see, what is, pull up a calculator. 22 squared, that's 484. That's going to equal 24 squared, which is 576. So if I subtract 484 from 576, I get 92. So x squared, I'll write it up here, equals 92. So by square root, x equals the square root of 92. Now, what divides into 92? What's the largest square number that divides? Oh, sorry, I wrote it over there. What's the largest square number that divides into 92? So if you start dividing by 2 and 2 again or whatever, you'll find that 4 times 23, 4 would be the largest square number, so x is going to equal 2 square root 23. Okay. Now, we have what we call special right triangles. Okay, now I'm going to talk about the special right triangles real quick here. There are 2 special right triangles. And they're classified by their angles. So first of all, you have a right triangle where these two sides are exactly the same, and the angles in here are 45 degrees. Because all three angles had to be 180. If those two are the same, then these two sides are the same. So this is called a 45, 45, 90. 45, 45, 90 right triangle, okay? Where this leg and this leg are the same. So the legs equal each other, okay? And the hypotenuse is a leg times the square root of 2. And that's how you find those. The other special right triangle is a 30, 60, 90 right triangle. So this one, since the sides are not the same, so in this one we have a definite longer side and a shorter side in the hypotenuse. So we call this one the short side. We call this one the long side. And we call this the hypotenuse. That's how we label those, okay? And then I have some formulas for these. So these go like this. So if you want to find the short leg or the short side, okay, that's always going to be half of the hypotenuse. Okay, so it's a formula you want right there. And if you want to use that same formula and solve for the hypotenuse, that's going to equal 2 times the short side, or the short leg. Okay, those are the same formula. All right. Now, the other ones that we use, if we're solving for the long leg, or the long side, okay, that we find by taking the short side and you times it by the square root of 3. So it'd be some number or whatever times the square root of 3. Or, anyway, okay. Well, let's rewrite this same formula for the short leg, or the short side. So that's just going to be the long side, or long leg, divided by the square root of 3. Those two go together. Okay. Now we're going to use those back and forth throughout this assignment, this lesson. Okay, so let's go up here to the 45, 45, 90, and we're going to figure out what these are. So if we were just saying, like, I don't know, if this side were some number and this side were some number, they would be the same. So if we just call them x, then they would both be the same, or whatever we want to call them. So we could say the legs equal each other, okay? And the hypotenuse is going to be, what did we say down here? The square root of 2 times one of those legs. So it would be one of the legs times the square root of 2. So whatever the leg is times the square root of 2. So if x was 1, then both of those sides would be 1, and this would be 1 times the square root of 2, which is square root of 2. So that's a ratio we want to remember. If those are 1s, we'll get to that. Okay, so let's go over here to fill in this information for 30, 60, 90. The short leg, if we call that x, let's say, we'll just call the short leg x. Then how does that relate to the long leg? Well, the long leg is the square root of 3 times the short leg. So the x times the square root of 3. Short leg times square root of 3 would be long leg. Hypotenuse is just double the short leg, so it's 2x. All right, that's how those fit together. So you want to keep that information. You want to refer back to those formulas I gave you on the left-hand side under special right triangles at the bottom as we go through this. All right, let's see. Example. What happened? There we go. Example next here, 2. Okay, we've got a right triangle. One angle here is 45, so this tells me that it's a 45, 45, 90. Okay, because if that's 45, this one has to be 45, because all three have to add together to be 180. So that tells me that these two sides are the same. So x is 10. And then we know that the hypotenuse is the square root of 2 times that side. So this would be 10 square root 2. You just write it like that. That's all there is there. Okay, this one. I see this also is a 45, 45, 90. So I know that x and y are the same, but we don't know what they are just yet, but we know this one is 16. So if we're going to go backwards in our formula, we know that if we take this side and times it by the square root of 2, we get this one. So if we go the other way, we'd have to divide. So if we take 16 and divide by the square root of 2, that's going to equal x and y. Okay? But we can't leave it with the square root in the denominator, so we got to simplify that. We're going to take 16 over the square root of 2. We're going to times the top and bottom by the square root of 2. So I get 16 square root of 2 over 2. Times the tops, times the bottoms. Square root of 2 times square root of 2 is 2. So 16 over 2 reduces to 8. So this is 8 square root 2. So that's simplifying our, it's called rationalizing the denominator. Remember that step where you don't leave a radical in the denominator or square root in the denominator? Okay, so that's going to happen a lot when you get to these questions, is we're going to end up with answers and we need to simplify them. Okay, this next one, this also looks like a 45, 45, 90. So let's use the 45, 45, 90 rule. So this looks like it's the same question as the one we just did. We have the hypotenuse, but we don't have a side. So if we take the hypotenuse, which is 4 square root of 2, and divide it by the square root of 2, then we'll get the side. That's what we did over here. Well, this is kind of nice. Those will cancel. So x and y are just going to be 14. Square root of 2's can reduce each other. Okay, what do we got here? So I see a 30. So this tells me this is a 30, 60, 90. So I go to the 30, 60, 90 rules. I have the hypotenuse. So if I have the hypotenuse, the easiest route is to go to the short leg, because we know that's half. All right, so x is half of the hypotenuse, or the short leg is half of the hypotenuse. So x would be 4. Okay? And then y, which is the long side is the square root of 3 times that short side. So it's going to be 4 square root 3. Okay, this is the easiest. If you're given to begin with the hypotenuse or the short side, okay, it's easy. It's the easiest way to find the rest of them. But I'm sure we'll be given the long side next, and then we have to divide by that radical. All right, so let's. Oh yeah, here we are. So in this one, it's a 60. This is a 30, 60, 90. Okay. So let's take the long side. I don't really have an equation to get from the long side right to the hypotenuse. I got to go long side to short side, then I can go to the hypotenuse. So if I look at my formulas over here that we talked about, if I have the long side and I need to find the short side, I just take the long side and divide it by the square root of 3. So the long side, which is 27, divided by the square root of 3, okay, that's going to give me the short side. So I need to take that and simplify it though. So I need to times by the square root of 3. So I'm going to have 27 square root 3 over 3. And then 27 over 3 reduces to 9 over 1. So 9 square root 3 is going to be the short side. And x is the hypotenuse, so I just need to times that by 2. So if I take 9 square root 3 and times it by 2, that's just 18 square root 3. We don't multiply the square root of 3. You just multiply to the 9. You don't need to multiply under the radical. Unless you add another radical, you'd multiply the radicals. But all right, so that's how we leave that. Let's see what we got over here. I'm given the short side. All right, great. So if I double that, I have the hypotenuse. So 5 square root 6 times 2, that's 10 square root 6. So that's going to be the hypotenuse. So that's x. And then if I take the short side, which is 5 square root 6, and I times that by the square root of 3, that's going to be the long side. So when you're multiplying, see these are radicals, so I'm going to multiply the radicals. I'm going to have 5 square root 18. Square root of 6 times square root of 3 is the square root of 18. But I need to take the square root of 18 and simplify it. So square root of 18, so let's write it over here, 5 square root 18. Largest square number divides into 18, that would be 9. So the square root of 9 times the square root of 2 times 5. So this is 3 times 5 is 15 square root 2. So that would be simplified. Okay. Pythagorean theorem and our two special right triangles. Okay, over the page 3. So if you have not downloaded that, or if you have a graphing calculator like the ones in class, pull it out. If you have not downloaded that graphing calculator, that TI graphing calculator to your desktop, you should do that. Those instructions were emailed to you. You could also, I think there's an app, I'm not sure exactly what it's called, but it is the TI-84, like the ones we use, app, and just on your phone it would be the same calculator. It would look exactly the same. So you can find that if you'd like. But you're going to want to be able to use the calculator. And if you don't have one, you can use just a basic scientific calculator, the one that has the 3 functions called sine, and on your calculator it would be SIN, it's the abbreviation, cosine, COS, and tangent, TAN. Okay, those are the 3 functions you need to see on your calculator. So on this calculator, they're just right here, sine, cosine, and tangent. So on whatever calculator you have, you'll need to be able to find those. And you're going to need to know how to switch or make sure that your calculator is in degree mode. Okay, so we're going to use our angles are going to be in degrees, so your calculator needs to be in degree mode or this will not work. Okay, so for our trigonometric functions, and we'll just say trig functions means first, what angle are we starting from? So if I'm starting from this angle, that's going to adjust the trig functions a little bit, or if I'm starting from this angle. It's always going to be one of the 2 angles, not the 90-degree angle. It's one of the 2 other angles where we'll start from. Okay. Now this little symbol right here, this little symbol, it's a Greek letter, and it's called theta. Okay, it's called theta. And that is used to denote, a missing angle. Okay, so let's read here. A trig function is a function whose rule is defined by a trig ratio, and we're going to talk about the ratios. A trig ratio compares the lengths of the sides of a triangle. Okay, comparing meaning as a fraction. And we use the Greek letter theta to represent the angle. Okay. So the sine function is the relationship from this angle right here, whatever that angle is. Okay, so in this case, in this figure, it's from right here. So starting in this angle right here, from this angle right here, if I draw a line directly across from that angle, that would be the side that's opposite that angle, okay? Now, C here is the hypotenuse. So that's always the hypotenuse because that's the longest side in the right triangle and it's opposite the 90-degree angle. That's where you always find the hypotenuse. Okay, so we always have the hypotenuse. So the other two things that we need to figure out are the side opposite and then this other one right next to that angle, if we're using this angle, okay, this would be the adjacent side. Okay, so you have two sides, opposite, adjacent, and then the hypotenuse. And our trig ratios are going to be fractions using opposite value, adjacent value, and the hypotenuse value. And the angle. Okay? Now that's different if we were going from this angle over here, say we were starting with this angle, okay? Then this side over here would be opposite. This side right here would be adjacent if we started from this angle. So it's always, you always have to reference what angle you're starting from so you know which value to use. Okay, so the sine function is the side that is opposite over the side hypotenuse. Okay? Which from this figure would be A over C. Opposite over hypotenuse. Okay? So we want to remember opposite over hypotenuse. That's the big thing to remember. Cosine, this is the side that is adjacent over the hypotenuse. Or from the figure, the side adjacent is B, because we're going from this angle, so this would be the adjacent side, B over C, which is the hypotenuse. So whatever those values are, okay, you would write them as that fraction. Tangent is the side opposite over the side adjacent. So from the figure, side opposite, since we're going from this angle, the side opposite is A, the side adjacent is B. So this would be A over B if you wanted to write it, depending on what it was that you're writing down, okay? Now, the way we remember the way we remember these trig functions is we say, okay, the sine function is opposite over hypotenuse. So we say so. The cosine function is adjacent over hypotenuse, ka. And the tangent function is the side opposite over adjacent. So we say SOHCAHTOA. If you can remember SOHCAHTOA, you can remember what goes with what trig function. Okay, SOHCAHTOA. There you go. Now these three trig functions, cosecant, secant, and cotangent, those are just the reciprocal of the ones we just did. So if you have the sine function, you just flip it over, and you have the cosecant, which then would be the hypotenuse over opposite. The secant is the reciprocal of the cosine, so that would be C over B, or hypotenuse over adjacent. And note, these are fractions, okay? And cotangent, flip it, so it would be B over A, or adjacent over opposite. Okay, so now let's see what we got here. Example 3, it says, find all 6 trig ratios. Okay, so the trig ratios are, there's the boxes for trig ratios. Let's adjust this real quick. There we go. So there's all 6 trig ratios. We need to write down the values. Well, first of all, when you have a right triangle, you'll need all 3 sides if you're going to write down the trig ratios. We have 2 of the sides. How are we going to find the third side? We'll call it C. If you remember earlier, the page before this, the Pythagorean theorem. So we could find it by going 16 squared plus 30 squared equals C squared. So on my calculator, I'm going to go 16 squared, 256, 30 squared is 900. So I'm going to go 256 plus 900. That's 1156. Now I'm just going to square root 1156. Oops. Square root 1156, and that gives me 34. So this side is 34. So now I can write down any ratio. So note where the angle is that we're starting from, right here. So from this angle right here, the sine function is the side opposite, which is 16, over the hypotenuse, which is 34. Reduce the fraction. So that's 8 over 17. And the cosine. So from that angle, the cosine is adjacent over hypotenuse. So that's 30 over 34. Reduce the fraction. 15 over 17. And tangent is the side opposite, opposite over adjacent. So that's 16 over 30. Reduce the fraction. Okay, that's how all those go. Now the cosecant, that is the reciprocal of the sine. So you just flip 17 over 8. The secant is the reciprocal of the cosine. So just take the reduced fraction and flip it. Okay? All right. Looking at example 4, okay, they're going to give us a ratio. So right here they gave us the cosine ratio. So I'm just going to draw a right triangle. Doesn't matter what it looks like. And I'm going to pick an angle. So I'm going to say this one, just because, no reason. And I know the cosine is 2 over 3. So if the cosine is 2 over 3, cosine is adjacent. So what's adjacent to this angle? That would be, this side would be opposite. This side would be adjacent because this one's the hypotenuse. So adjacent over hypotenuse. Okay? So I'm going to draw the triangle. I'm going to put in the values to the correct sides according to the trig ratio of cosine. Adjacent over hypotenuse. From this angle, this would be adjacent. All right, so now I need to find the other side. So I'm going to have 2 squared plus, we'll call that b. b squared equals c squared. A squared, b squared, c squared. So this is 4 plus b squared equals 9. B squared would equal 9 minus 4, which is 5. And we square root both sides, so b is the square root of 5. Okay, so now I fill that in. Now I can just go and fill in my ratios here. Starting at this angle, sine is opposite over hypotenuse. So that's the square root of 5 over 3. We don't have to reduce that because they don't reduce. Cosine we already have. Tangent is opposite over adjacent. So that's square root of 5 over 2. Okay? Let's see. The cosecant, so I need to flip this. So that's going to be 3 over the square root of 5. Now I can't leave the square root on the bottom, so I'm going to times the top and bottom by the square root of 5. So that's going to leave me 3 square root 5 over 5. Just to kind of break that up a little right there. And secant, I've got to flip that over, so 3 over 2. Cotangent, I flip this over, so 2 over the square root of 5. So I'm going to times by the square root of 5 to get rid of that. I have 2 square root of 5 over 5. Just kind of do that. Okay. Oh, there we go. So I went 2 over square root of 5 times top and bottom by square root of 5. 2 square root of 5 over 5. All right, let's see. Let's see, angles 30, 60, and 45 are used frequently in trigonometry. You can use your knowledge of the side relationships that we just barely talked about in special right triangles to find the values of the trig ratios. Okay, so for example, when we went back up there, we're doing the formulas where we said, okay, if these sides were both x, okay, well, let's say if each side was both 1. In a 45, 45, 90, those two are the same. So if I go 1 and 1, the hypotenuse is the square root of 2 times this side. So this is just square root of 2 times 1, which is square root of 2. So that's a standard ratio for a 45, 45, 90 right triangles. You have, standard side length for just the ratio of a 45, 45, 90 right triangle. 30, 60, 90, if we called this one, then we know that this is double, and then this side is the square root of 3 times that. So square root of 3 times 1 is square root of 3. So those can be your basic ratios. So if we go to a 45 angle, okay, we're going to use this triangle. So pick one of the 45s, it's not going to matter, sine and cosine, or 45 and 45, and either one is going to be going to work. So I'm going to pick this 45. So 45 sine means opposite over hypotenuse. So 1 opposite over hypotenuse square root of 2. And then I have to simplify it because I have that radical in denominator. So this is square root of 2 over 2. Okay, so that's your standard sine of 45 ratio, square root of 2 over 2. Cosine of 45. So if you stay there, cosine, adjacent, 1 over hypotenuse, square root of 2. Oh, that's the same as what we just did. So we could just write that down, square root of 2 over 2. Those are the same. So sine and cosine of 45, okay, they are the same. Okay. Tangent of 45, well, opposite over adjacent, that's 1 over 1. So the tangent of 45, its ratio is just 1. All right, let's go to our 30, 60, 90. Sine of 30, so we're going to go to our 30, 60, 90 right triangle. Sine of 30, so sine is opposite over hypotenuse. So that's 1/2. Sine of 30 is 1/2. Cosine of 30, adjacent over hypotenuse, so square root of 3 over 2. There's your standard cosine of 30. Tangent of 30, so that's opposite over adjacent, so that's 1 over the square root of 3. Simplify it. Oh, where are we? Oh. All right, so sine of 30. If I need to kind of break that down a little. Sine of 30, backing it up. Sine of 30, 1 over the square root over 2, opposite over hypotenuse. Cosine of 30, adjacent over hypotenuse, so square root of 3 over 2. Then tangent of 30 is going to be opposite over adjacent, so that's 1 over the square root of 3. Then you simplify, and you get square root of 3 over 3. Okay? Now if we go back, remember the... Okay, so here, sine of 60 now, we go from the 60-degree angle. Sine is going to be opposite, which would be square root of 3 over hypotenuse, over 2, the square root of 3 over 2. Cosine of 60, so you go from the 60-degree angle. Cosine is going to be adjacent over hypotenuse, so 1 over 2. And then the tangent of 60 is going to be opposite over adjacent, so square root of 3 over 1. So that's just going to be square root of 3 over 1. Okay, if you notice, the sine of 30 and the cosine of 60 are the same in both cases. So the sine of one angle is the same as the cosine of the other, so if you know one of them, you can find the other, basically. Okay. Remember, if you have questions, there's an answer key. You can email me, get a hold of me, start a discussion in Canvas, and you guys can talk to each other or talk to me or whatever you need to do. All right, so on your assignment, page 4 here, it says find each missing length. So you're going to do exactly what we were doing. We have Pythagorean theorem, okay, to begin with. And then 7 and 8, you're just going to write down the 6 trig functions. So you got to find the third side using Pythagorean theorem, and then fill in the ratios, simplify all the ratios. And then basically what we just did, okay, they're giving you one ratio, draw your triangle, fill that in for 2 of the 3 sides, find the third with Pythagorean theorem, and then fill in the rest of your trig ratios. Same thing here on number 10. 11 through 16, you want the exact ratio. So it's what we just did at the end of those notes. The 45, 45, 90 was 1. The legs were 1, the square root of 2 was the hypotenuse, and then the 30, 60, 90, the short side was 1, hypotenuse 2, and the other length was square root of 3. Or maybe I'm thinking you could do the calculator. On your calculator, if you want to find the sine of 45, you would just hit the sine button. 45. Now, if your calculator is in degree mode, you're going to get the right answer. So there's the 0.707. All right, so my mode, degree is highlighted. Good. Okay, so 0.707 would be the decimal. Okay, sine of 45 is the square root of 2 over 2. So if you take the, you could find it that way. If you did the square root of 2, divided by 2, that's square root of 2 over 2, you get that same decimal, 0.707. All right. Let me know if you have questions, and I'll get the next unit loaded up probably tomorrow.